So in this video, we are going to look at differential geometry, and we are going to look at four things. So the first one is we are going to look at unit tangent. We are going to look at unit tangent. The second one is we are going to look at curvature. And then we are going to look at the radius of curvature. Then we are going to look at the principal normal. So these are the four things that we are going to learn from here. All right. So before we start, let's look at the formulas for each of them before we just get it started. Right. So for us to find for unit tangent, we are going to say that this is equal to r prime, which is the position vector, divided by the magnitude of r prime. And we learned from the previous video that r prime, which is the same as dr over dt, was the same as what? The velocity. So it means that this one can be written as the velocity divided by the magnitude of what? The velocity. So basically that is the unit tangent. So basically this video, all we just need to know is the formulas, and we can take some examples. Then curvature is equal to the unit tangent derivative divided by the derivative of the unit tangent magnitude, or magnitude. So this is very nice. So it means that here, when you get the unit tangent wrong, it's automatically going to affect this one. So we differentiate the unit tangent that we are getting here. We find the magnitude, we divide, then when we finish, we find the magnitude again. Now the radius of curvature is just equal to 1 divided by the curvature, right? And then the last one is the principal normal, which is the unit tangent divided by the magnitude of the unit tangent. So these are the things that we need to do. Oops, I think this one is supposed to be r prime. This one's supposed to be the position vector, right? So this can be written as this divided by the velocity, because r prime is a velocity or magnitude. Good. So this is what we are going to get. So these are the four formulas that we are going to use to solve the example. So let's take some examples and then see how we can go through that. So we are given a space curve, right? X, Y, and Z. And we want to find the unit tangent. So the first thing that we need to do here is to form the parametric equation. So what's the parametric equation that we need to form here? Our r of t should be equal to xi plus yj plus zk, right? So we know r will be equal to x is 3 cos t I plus 3 sine t j plus 4tk. So this is the r that we need to form using the functions here. Then now we can find the unit tangent. Now we know that unit tangent is equal to r prime divided by the magnitude of what? R prime, which is the same as the velocity divided by the magnitude of the velocity. So with this one, all you need to know is you know the formula and you know how to do the differentiation, right? So let's go through the process and see what we are going to get. We need r prime. So what is r prime? Let's differentiate this. So here too, your differentiation should be very good. So when I differentiate cos, I'm going to get minus sine. So this is going to give us minus 3 sine ti. When I differentiate sine, I'm going to get cos. So I'm going to have plus 3 cos t j. And when I differentiate 4t, I'm going to have plus 4k. So this is my r prime. So I need to find the magnitude of r prime. So that's what I just need to do. And we know that r prime is the same as the velocity. So we can have that. So now let's find the magnitude of r prime. So this is equal to square root of, I pick the coefficient of I square it. So I'm going to have minus 3 sine t all squared plus the same thing for j cos t all squared plus the same thing for k squared. So let's simplify that. We are going to have square root of 9 sine squared t plus 9 cos squared t plus 16. So what are we going to get? This is the same as, now I can factor 9 out and have sine squared t plus cos squared t plus 16. So here I factor the 9 out, factor 9 out, I'm going to have this. So as I said, this repeats itself when we are dealing with this kind of questions. So this is going to give us 1. And remember, this is positive. So this is going to give us square root of 9 times 1, right? Square root of 9 times 1 plus 16, and this is the same as square root of 9 plus 16, which is the same as square root of 25, and this is going to give us 5. Good. So now we can find the unit tangent. So we know that unit tangent is equal to r prime divided by the magnitude of that. What was r prime? We had minus 3 sine t I plus 3 cos tj plus 4k. Then we divide it by the 5, which is the magnitude. So basically, that's what you are going to get. And if you want to simplify this, then we can just, since this is going with directions, we can write this one as minus 3 divided by 5 sine ti plus 3 over 5 cos tj plus 4 on 5k. So this is the unit tangent. Let's look at the curvature, right? So we know that curvature is equal to the unit tangent divided by the magnitude of r, or magnitude, right? So now we know that we found the magnitude of r, and we had 5 from here. So that's what we had here. The magnitude of r here, r prime here is 5. So we have that one here. Now what is the unit tangent, or t prime? So now from this question, we had t to be equal to this. So I'm going to write this one, and then we differentiate it. So t prime, sorry, t is equal to minus 3 divided by 5 sine t plus 3 divided by 5 cos t I and j plus 4 over 5k. So I think that's what we had. Right. So now that we have magnitude of r prime here, we just need to look for t prime. So let's find for t prime. Now t prime is equal to, let's differentiate sine. We get cos. So this is going to give us minus 3 divided by 5 cos ti. And when I differentiate cos, I'm going to get minus sine. So this changes to minus 3 over 5 sine tj. Then when I differentiate this, there is no t, so it's a constant. So when I differentiate it, I'll get it to be 0. Good. So what am I going to do? I need to find t prime divided by the magnitude of r prime. Then when I'm done, then I find the magnitude. So let's do that. So I need t prime divided by r prime magnitude, which will be equal to, so t prime is, so here I can factor minus 3 divided by 5 out. So I'm going to have cos ti plus sine tj. Good. So if that's the case, this is going to give us minus 3 over 5 open bracket cos ti plus sine tj divided by the magnitude of r prime, which is equal to 5. So this is going to give us this. Then if I have something like this, so we can see that we have the scalar here, we have scalar here. So if I have minus 3 divided by 5 divided by 5, so this is minus 3 divided by 5 divided by 5. So I'm writing it this way. This is the same as minus 3 divided by 5 times this is divided by 1, so 1 over 5. So this is going to give us minus 3 divided by 25. So that's what we are going to get from here. So this is going to give us minus 3 divided by 25 in bracket cos ti plus sin t j. So the last thing that we need to do here is now we need to find the magnitude of the result that you've gotten here to give us the what we need, right? So let me just shift this guys to this place, right? And then bring this one to up. So now let's see what we are going to do. Let's just find the magnitude of that. So the curvature, which is k, k is equal to the magnitude of t prime divided by r prime magnitude or magnitude. So now let's find the magnitude. So everything in this bracket here is equal to this. So we want to find the magnitude. So what we need to do is anytime I want to find a magnitude and I see a scalar, right, multiplying the function, this is a scalar. I just need to, if it is minus, just ignore the minus, because when you put it under this, you are going to just do like minus 3 over 25 squared, and the squared, and then you see that the square here, so let me just write minus 3 divided by 25 all squared, and you see that the square will square the minus and make it positive, and this is going to give us 3 over 25 all squared, and square will cancel this. So because of that, I don't even need to write it. So since this one is a scalar, I will ignore the minus and then write this one as, or let me see, I can write this one as 3 over 25, and then this is minus cos t I plus minus sin tj, right? So I just multiply through by the minus so that I can just maintain the scalar. So I'll have 3 over 25 out, then I'll pick my square root. And as I said, you can just use the same thing for this one too. All you just need to do is ignore this because you are finding the magnitude. Because when I find the magnitude of this scalar constant here, it will make this one positive. So now let's look at this. This is going to be, if I'm using this one is going to be minus cos t squared plus minus sin t squared. And let's see the magic. So 3 divided by 25 square root of this one is cos squared t plus sin squared t. So as I said, you will be seeing this a lot when you are dealing with sine and cos. And this is 2 over 3 over 25 square root of 1. And this is 3 over 25 times 1. And this is going to give us 3 over 25. So this is the curvature. And then we know that the radius of curvature is actually 1 divided by the curvature. So this is going to give us 1 divided by 3 on 25. And this is the same as 25 divided by 3. So you see that this is very simple, very, very simple. All we need to do is we should be able to know how to differentiate and know the formulas. That's all that we just need to do. Let's look at the principal normal. So the first thing that we need here is, what is the formula for finding principal normal? As soon as we identify the formula, then we are good to go. So we know that principal normal is equal to the unit tangent prime divided by the magnitude of unit tangent prime. And we've already found t prime, which is the unit tangent. So you see that this question is kind of dependent. So if you get one of them wrong, it means that it's basically going to affect everything. And that's what happened here. If I get forming this one wrong, it means that, or let me say, differentiating this one wrong, it means that it's going to affect this, are going to affect this, and automatically affect the radius, and then also affect this one too as well. So let's pay attention from there. So now this is my um t prime, right? This is my t prime. So let's see what we are going to get from there. So t prime was equal to minus 3 over 5, then cos ti plus sine tj. So since we have this here, all we just need to look for is we need to find the magnitude of t prime. So magnitude of t prime is equal to, so as I said, the same thing here. This is a scalar, so I'll just maintain the 3 over 5 because I'm finding the magnitude of this and it just get to positive. Then when I find the magnitude of this is actually, I'm finding the square root of cos squared t plus sine squared t. So let me just do it this way, squared, and then do it this way also, squared. So you see that this is going to give us 1. So 5 square root of cos squared t plus sine squared t, and this is going to give us 3 over 5 square root of 1, 3 over 5 times 1, and this is 3 over 5. Indeed. So all we just need to do is we just need to divide and we are done. So the principal normal is equal to the winning tangent here divided by this. So I'm going to have minus 3 divided by 5 cos ti, right, plus sine tj divided by 3 over 5. So we can see that this is 3 over 5, this is 2 over 5, cancel out, and we are going to have it to be minus. And when I multiply through the minus, I'm going to have minus. So, or if I maintain it, let's say cos ti I plus sine tj. So this is what I'm going to get at the end of the day with this one. So you see that this aspect is very simple, and this is like kind of questions that they are basically, exams or something. You get some there. So if you know how to do this and you go and this there, it's good for you to just get your head through. Now let's look at one last example. Then I'll give you one trial question before we start differential equation. I love differential equation a lot, so we will do differential equation in the next video. So now let's look at this one again. Here we want to find the velocity and then acceleration, and then when you finish we need to multiply the r to vin to get what, like, evaluate it and see what we are going to get. So same thing that we need to do again. So this is basically what we did in the previous video. So what is the formula for finding velocity, right? So we said the velocity, which is vin, is equal to the r over the t. It's not always divided by the t. We do the t because the function is in terms of t. So if the function changes and it goes to, let's say, u or anything, then you need to change this one too as well. But first we need to form r. R is si plus yj plus zk. So this is going to give us et sine ti plus et sine, one of them is supposed to be cos, this one's supposed to be cos, good, and then j plus et k, right? So this is my r, right? So now I can find the velocity now. So my velocity is equal to, now let's differentiate this. So as I said here, your derivative is very important, how to differentiate. And math, it's all about knowing how to differentiate, knowing how to integrate. If you know how those kind of things, then when you are doing calculus, is kind of very simple, simplest course in this world. So let's do something like this here. Let's differentiate this. This one we need to use the product rule, right? Because we have two function multiplied. So I can just think of like picking a to be equal to e to the power t and b to be equal to cos t. Then what is a prime? A prime, when I differentiate an exponential function, I maintain the function, and then I differentiate what is on the top. So when I differentiate t with respect to t, I'll get 1. So 1 times this is the same thing. So when we differentiate an exponential function like this, you get the same thing. It's not always. And then when I differentiate cos, we know that we need to have minus sine t. So for me to differentiate the I direction, I need to multiply this one to this and this one to that. Good. So I'm going to have my vein to be equal to, so this is going to be cos t e t minus sine t e t I. So this is just the I direction. Then I need to go to the j direction. So j direction is almost also the same thing. So I pick my a to be this, I pick my b to be sine t. Then what is sine t prime? This is going to give us cos t. So same thing, this times this, and then this times that. So I'm going to have plus, so I'm moving to the j column, so I'm going to have cos t e t plus sine t e t. Then I have j. Don't forget, with product rule, it's plus, but the first one, because when I differentiate cos, I'm getting minus. That's the reason why this is minus here. Then the last one is just e to the power t. So when I differentiate e to the power t, I get e to the power t, and then I have k. So this is what we are going to get as the velocity. Let me write it in this place so that we can see the actual process, like what we have. Good. And then plus this. So this is the velocity, right? We need the acceleration. So it's kind of, this kind of questions are very a lot. So acceleration is equal to dv over dt. So it means that we need to differentiate the velocity. So let's do that. Same idea here. So you see that this one is like product rule again. This is another product rule again. This is another product rule, and this is another product rule again. So it's a lot of work that we need to do here. So the same idea, anytime you are doing product rule, the same idea here, right? So if I'm doing with cos, so if I'm dealing with cos, I'll just do them straight away. So the first component here, this is what you are going to get. I maintain cos, differentiate e to the power t, and I'm going to have e to the power t plus, then I maintain e to the power t and differentiate cos, which is going to give us minus sine. So we are going to have the same thing here. So this is one component. It's just for this. Maintain cos, differentiate e to the power t, maintain e to the power t, differentiate cos, and we have this. Then minus, I open parenthesis, I do another product rule here. I maintain sine, then differentiate e to the power t. I'm going to have e to the power t plus, now I maintain e to the power t, differentiate sine, I'm going to get cos. So this will be cos t e t. Then this is just the I direction. This is just the I direction. Then I move to the j direction. So plus the same product rule again, right? But remember, we've done them already. We've done cos t to the power et, which was the same as this, and this is what we had, right? And then we've done sine t et, which is also the same as this, and this is what we had. So we repeat them. The only thing that is going to change is the sign here. This is minus and this is plus. So I repeat everything. So I'm going to have cos TET minus sine TET plus, because this is plus. So now I'm differentiating this, and I'm going to have sine TET plus cos TET, and this is the j direction. And then plus, when I differentiate the last term, I get the same thing again. This is indeed nice. Now let's try and see if you can simplify. Yes, we can do that. I think this guy can cancel this guy. Is that true? Yes. And then when I multiply the minus through this, cos will cancel the cos here, right? So from here, okay, let me just simplify the top there. So I'm going to have something like this. So from the top, I'm going to have cos TET minus sine TET. Then when I multiply through by the minus, I'm going to have minus sine TET minus cos TET, or I. So you see that this will cancel that, right? Then plus, now this cancel this and this are the same, so I'll add it and get 2 cos t e to the power tj, then plus e to the power tk. Then when I cancel this and this, I can add this and this. So I'm going to have, finally, I'm going to have minus 2et, sorry, sine et I plus 2 cos TETJ plus ETK. So this is the acceleration. Now the last thing that I need to do is to dot R and Vin, right? So let's do that. Let's dot R and Vin. Good. So I can clean this one here and just dot them up here. So R, oops, I think I cleaned my R. So I have my R here. So let me just maintain my R here. Good. So R dot Vin is equal to, so R is equal to this one here. So we have ET cos TI plus ET sine TJ plus ETK dot Vin. What do we get for Vin? Vin is the whole of this. So I can even copy it and just paste it there. So let me copy this guy here and make it paste. Good. So we are dotting this with to this. So let me just clean this one here. So we are doing this times that. So we know how to do dot product, right? We do direction by direction. So I goes with the I here, J goes with the J, and lastly K goes with K. So let's do that. This times this will be e to the power t cos t times cos TET minus sine TET, right? Plus, then this guy will multiply the whole of this. So I'm going to have ET sine T, open bracket, cos T, ET plus sine T, ET. Then the last one will be plus ET times ET. So that's what I'm going to get. Remember, whenever we do dot, we need to get a scalar. So we don't have the ij key again. So when I multiply this one to this, I'm going to have something like this. E to the power 2t cos squared t minus e to the power 2t cos t sine t, right? So when I multiply this to this, e to the power t times e to the power t will give us 2t, e to the power 2t, cos times cos is this, and then when I finish, I multiply this one to this. Then plus the same thing here, this is going to give us e to the power 2t cos t sine t, right? So multiply this one by this, and we have this one here. And then plus e to the power 2t sine squared t. Then plus e to the power 2t. Interesting. Now we see that this guy will cancel this guy, right? Indeed, we see it from there. And then we can simplify some terms here. Now this will be left with e2t cos squared t plus e2t sine squared t plus e2t. So this will be left. And then we can factor e to we can factor this, this, and this out. So when I do that, I'm going to have this, and this will be left with cos squared t plus sine squared t plus 1. So I just factored e to the power 2 out, left with this, this, and 1. Now we know that cos squared plus sine squared is also equal to 1. So this is this, and then 1 plus 1, and this is e to the power 2t times 2, and this is going to give us 2e to the power 2t. Good. So this is what we are going to get when we dot r to v. So this one needs like kind of simplification and how to do the derivatives. So please practice on that and then you'll be fine. So this is A. Let's do B. So B, we want to find the unit tangent. So what's the formula for finding the unit tangent? Unit tangent is equal to r prime divided by r prime magnitude. So we've done r prime already. Oops, I cleaned it. I cleaned that. I cleaned that. I cleaned that. Okay, it's here. So remember, r prime is the same as the velocity. So this is what we had. So I will just write this one. It's here. It's the same as the velocity. So we said this is the same as v divided by magnitude of v, right? And then we saw that the velocity is equal to cos sine. So cos t I, no, cos t e t I minus sine t e t j. This should be out there. Okay. I plus, then this one was cos t e t plus sine t e t j plus e to the power tk. So I think that's what we had. Yeah, that's what we have for the velocity, which is the same as r prime. So don't forget, this is the same as r prime. So for us to find the unit tangent, we need the magnitude. So let's find the magnitude. I love anytime I'm dealing with this kind of thing. You see that it is going to simplify very nice, because when you find the magnitude, we are going to have sine squared and stuff, and everything will be simplified. So let's see. This is cos t e t plus no minus sine t e t all squared plus cos t e t plus sine t e t all squared plus e t all squared. So we are finding the magnitude. Pick the coefficient of I, coefficient of j, and that. And we just do it. Somebody is asking, why are we picking the coefficient? Because even if I add the I here, when I square the I squared is 1, right? Because we are dealing with vectors. So I squared is 1. So we just need to pick the coefficient and we are done. Let's see something here. Now, what I'm going to do is I'm going to take them one by one and then expand, right? So let me just pick cos t e t minus sine t e t squared and then expand. This is the same as cos t e t minus sine t e t times cos e t minus sine et, right? So let's do the expansion. This times this, so it's going to give us cos squared t e 2t, right? Then this times that, I'm going to have minus sine t cos t e t. Then I multiply this one two by this, so I'm going to have minus another sine t e cos t e t, and then the last one will be plus sine squared t e squared t. So when I expand, that's what I'm going to get. And then when I simplify this, I'm going to have cos squared t e squared t minus this term, and this term is the same. So I'm going to have 2 sine t cos t e t plus sine squared t e squared t. So anytime we are finding the magnitude, you see that when we square it, we have this and that. So we can just basically try to squeeze it in a way that it is going to, you know, go to, this one's supposed to be 2t. This one's supposed to be 2t. So this will be 2t. So what I can do here is I can factor e to the power 2t out, and this one will be left with cos squared t. Then I'll bring this one again. So when I do this, I want to bring this one. So when I factor this one out, it will be left with sine squared t plus sine squared t minus, when I factor this one out, it will be left with this one, which is minus 2 sine t cos t. So we know that this guy here is going to give us 1. So we are going to have e squared 1 minus 2 sine t cos t. Then when I multiply it back, I'm going to have e2t minus 2 sine t cos t e2t. So this is the first term in the bracket here. So it means that this is equal to this. So the first term here, this is the same as e to the power 2t minus 2 sine t cos t e to the power 2t. So that's the first term that we've gotten there. Now let's look at the second term. Now when you look at the second term, it follows the same thing. The only thing that is changing here is changing to plus. So I'll just make this one plus, and then when I do it, this one become plus, this one also become plus, this one will be plus, 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 and then this one will be plus, and this one will be plus, and this one will be plus. That's all. Right. So it means that this term here too is going to give us e to the power 2t plus 2 sine t cos t plus, then when I square this, I'm going to have 2t. Good. So that is what we've done now. Right. So now let me clean and then let's finish it up. So now that we've seen this, I'll write this one as square root of, so this one, when we simplify, that's what we are getting. So we are having 2t minus 2 sine t cos t e to the power 2t plus e to the power, oops, I think I left something here. This one should go with e to the power 2t. Good. So plus 2t plus 2 sine t cos t 2t plus that. And then the magic happens. That's all the magic that we were looking for. And then this one will be left with square root of, so I have this and this. When I add, I'm going to have 2e to the power 2t. And this is the same as square root of 2 times square root of e 2t, right? And this is also the same as square root of 2. This is the same as e to the power t all squared, and then the squared cancel this. So it means that this is basically equal to root 2 et. So that is the magnitude of vein. So now we can write the unit tangent. So you see that there is a lot of work, a lot of expansion here that we need to do. So it means that we are going to have this one to be, let me see, cos t e t minus sin t e t I plus cos t e t plus sin t e t j plus e to the power t k. Is that right? Yeah. Then we are going to divide all of this by square root of 2 et. But let's see something here. You see that we have et here, et, 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 et throughout. So we can factor it out so that we can cancel. Because when you are dealing with this one, the best way to do this is to look at like simplification. Cancellation should be able to be canceling some of the terms so that your simplification, because remember we are going to use the unit tangent to solve other things too. So if we're able to simplify it, it actually helps us to reduce the complexity when we are dealing with other stuff. So I will factor e to the power t out. So this one will be left with cos t minus sin t I plus cos t plus sin t j plus k, all divided by square root of 2et, and then this guy will cancel this guy. So it means that now this one was simplified to cos t plus sin minus sin t I plus cos t plus sin t j plus k divided by square root of 2. So this is the unit tangent that we are going to get, right? So basically that is how the thing is. Like, you should be able to know how to do the simplification very well, and then you are okay to go. Now I did the simplification because we are going to use this one here to calculate the curvature, right? So we know that for curvature, which is t, which is k or kappa, this is the magnitude of t prime divided by the vein, which is the vein there is the same as r prime. So don't forget when I'm misusing my notations. So we know vein prime already. Vein prime is already here, which is, we are excited to see that this one was equal to, so magnitude of vein was equal to root of 2e to the power t, right? That's what we had from here. So now what we just need to do is we need to find t prime. So we've gotten t to be this. So let me just write t this to the other side. So we've gotten t to be equal to cos t minus sin t all I plus cos t plus sin t all j plus k divided by root 2. Good. So that's what we had from here. So now let's find t prime because that's what we need, right? Good. So t prime is equal to, now let's differentiate cos. When you differentiate cos, what do you get? Minus sine. When I differentiate sine, I get cos. So this will be cos t I plus, same thing for the other one. I differentiate cos, I get minus sine. Then I differentiate sine, I get cos j. Then here there is no t in the k direction. So when I differentiate it, I'll get it to be 0. Then I'll divide it by root of 2. Good. So basically that's what we are going to get. So now that we have t prime and we have the magnitude of vein, then we can just divide. So now t prime divided by the magnitude of vein is going to give us minus sine t minus cos t I plus minus sine t plus cos t j divided by square root of 2. So everything written here is basically t prime, and this is divided by the magnitude of this. So instead of going divided by, I'll go it this way, divided by, using this sign, divided by root 2 e to the power t, because divided by this and this is equal to that. Then I can write this one as minus sine t minus cos t all I plus minus sine t plus cos t all j divided by square root of 2 times, this is divided by 1, so I can write this one as 1 divided by square root of 2 e this. Then multiply. So our final results here should be minus sine t minus cos t I plus minus sine t plus cos t j all divided by, then square root of 2 times square root of 2 is 2. So I'm going to have 2et. Good. So that is the curvature here. And then we know that the radius of curvature is basically equal to 1 divided by the curvature, right? So it means that the radius will be equal to 1 over this, will reciprocate it. So we are going to have it to be 2et divided by minus sine t plus minus cos t I plus minus sine t plus cos t j. So this is what you are going to get at the end of this. Let's do the last one, then I'll give you trial question to do. Now the last one is the principal normal, right? So we are saying that this is t prime divided by t prime magnitude. So we have t prime here. So all we just need to do is to find the magnitude, right? And then we are done. So let me just copy t prime to the next page so that we can use it. Okay, so let's see. This is t prime. So we just need magnitude of t prime and then we are done. So as I said, anytime you are dealing with this and you have a scalar, you can just bring the scalar out. So the scalar here is 1 divided by square root of 1. So I can factor 1 square root of 2 out and then now find the magnitude. So magnitude of this one squared and that one squared. I just factored this one out. So I'm going to have minus sine t minus cos t squared plus minus sine t plus cos t all squared. So let's do the same thing. Let me pick the first term, expand, do same thing for this one, and then we are done. So minus sine t minus cos t all squared. This is the same as minus sine t minus cos t times minus sine t plus cos t. No, minus cos t. So let's multiply. Sine times sine is sine squared t, and then sine and cos will be plus sine t cos t, another plus sine t cos t, and then plus cos squared t. So distribute this to this to that, this to this, and then this to this. So simplify, and we are going to have sine squared t plus, I'll bring this guy to close to this. Then when I simplify this, I'm going to have 2 sine t cos t. We know that this guy here will be 1, so we are going to have it to be 1 plus 2 sine t cos t. So this is the expansion for this. Let's try this one too. So this one is minus sine t plus cos t squared. So this is minus sine t plus cos t, then minus sine t plus cos t. Let's simplify again. Simplify them. This is going to give us sine squared t minus sine t cos t minus sine t cos t plus cos squared t, right? So distribute this and that, and then this is what you're going to get. So I'm going to have sine squared t. I'll bring this one close to this. So plus cos squared t minus 2 sine t cos t. So this is going to give us 1 minus 2 sine t cos t. So we are done with the simplification, this. So let me try and then write them. So when we simplify this, we had this. So we had this. And then when we simplified this one too, we had that. So let me just send them up there and let's see what we are going to get. So it means that now we are going to have this one to be 1 divided by square root of 2 square root of, then this is equal to this. So I'm going to have 1 plus 2 sine t cos t plus, When we did this one too, we had this. So I'm going to have plus 1 minus 2 sine t cos t. And then the magic happens. This will cancel that. So we don't need this one again. So this will be equal to 1 divided by square root of 2 times. Now this will be 1 plus 1 and 1 over square root of 2 times square root of 2. Wow. And this is going to give us a big 1. So this is what you are going to get for the principal normal. So I will stop here and give you this trial question to try. First, determine the velocity acceleration, and then you work through this and you put your final results in the comment section. See you in the next video. So in the next video, I'll try and prepare a quiz question that is going to cover let me say the vector algebra question, everything that we've done, and then right after the quiz video we can think of differential equation. Are you ready to start differential equation? Then see you in the next 2 videos.